Elon Musk has once again made headlines with a groundbreaking revelation that has sent shockwaves through the aviation world. In collaboration with the U.S. Air Force, SpaceX has unveiled a $4 billion aircraft that promises to revolutionize the skies. Equipped with cutting-edge technology and unparalleled capabilities, this innovative aircraft is poised to redefine the future of air superiority. But what makes this new jet so special? And how does it compare to the United States' sixth-generation aircraft? Join us as we uncover the secrets behind Elon Musk's $4 billion aircraft. SpaceX has discreetly acquired a Boeing 737-800, painting it in a sleek gray and black design. While the exact purpose of this aircraft remains unclear, speculation suggests it could serve as a corporate shuttle, a testing platform, or both. The unique paint scheme and potential uses have drawn comparisons to some of the world's most secretive 737s. The Boeing 737's journey began in the early 1960s, when it was designed to complement the Boeing 727. Originally intended for short-haul routes, the 737 quickly rose to prominence, eventually replacing the 727. Production of the 737 began in 1960-1986, following Lufthansa's receipt of the first model. Since then, over 12,000 units have been produced, and the latest variant, the 737 Mach, continues to see strong demand with nearly 5,000 additional orders. SpaceX's Boeing 737-800 is part of the 737 Next Generation series, which debuted in 1993 to replace older models. This series features improved wing designs, enabling greater fuel capacity and higher maximum takeoff weights. Powered by CFM International CFM 56-7 engines, the aircraft delivers over 27,000 pounds of thrust. Boeing also enhanced avionics and introduced new interior options, making the 737-800 a formidable aircraft. In addition to the Boeing 737-800, SpaceX also operates a Gulfstream G450. According to Jet Spy, this plane, built in 2007, is registered as N450GG. While the Federal Aviation Administration lists TVPX Aircraft Solutions as the registered owner, reports indicate SpaceX utilizes the aircraft. In 2024, the Gulfstream G450 completed 150 flights, accumulating significant flight hours. These flights consumed nearly 170,000 gallons of fuel, resulting in 1,610 metric tons of carbon emissions. The top destinations for the G450 included Draft and Miller Central Texas Regional Airport, Jack Northrop Field Hawthorne Municipal Airport, and Brownsville South Padre Island International Airport. The Gulfstream G450 traces its lineage to the Gulfstream 4, which debuted in the 1980s. The original Gulfstream R4 featured an extended fuselage, new engines, and enhanced avionics. The first prototype took flight in September 1985 and entered service in 1987. The G450, introduced in 2004, boasts even more upgrades, including Rolls-Royce Tay 611-8C engines with nearly 14,000 pounds of thrust, advanced avionics, better flight controls, and improved landing gear. But what does Elon Musk's newly acquired aircraft have in common with the United States Next Generation Air Dominance (NGAD) fighter jet, if anything? The NGAD program represents the future of aerial warfare, featuring advanced technologies and unmatched capabilities. These sixth-generation fighter jets are designed to transform air combat, offering stealth, hypersonic speeds, artificial intelligence integration, and advanced sensor systems. While Musk's aircraft may not match the NGAD's combat capabilities, its cutting-edge design and advanced systems hint at parallels in innovation and engineering. Both platforms showcase the potential for next-generation technologies to shape the future of aviation. And now let's see how the SR-72 aircraft developed. The SR-72 isn't just an aircraft, it's expected to become the U.S. Air Force's trump card. Yet, for over a decade, concrete details have remained shrouded in secrecy. Only a few conceptual images and cryptic leaks have emerged, leaving experts and the public restless with anticipation. Most intriguingly, the U.S. Air Force has neither confirmed nor denied the project's existence. Does the SR-72 truly exist? Or is it merely a smokescreen to conceal another secret weapon? Where does the truth lie? This question continues to intrigue and challenge the curiosity of the entire world. The SR-72's typical combat scenario is nothing short of impressive. It bypasses enemy air defense systems with hypersonic speed, conducts reconnaissance on the target, and retreats safely afterward. The identified air defense positions are then attacked with missiles or artillery, paving the way for air and ground forces to carry out subsequent operations. Imagine a fighter aircraft capable of reconnaissance, guidance, and precise attacks, all in a short span of time. What are your thoughts on such a capability? Share them in the comments below. Another advantage of hypersonic aircraft is their ability to support hypersonic missiles. Let's take the battlefield in Ukraine as an example. Russia has used MiG-31K fighters to launch the Kinzhal hypersonic missile. In 2019, at the Dubovich testing range, the Kinzhal made its debut during the Aviadarts 2019 competition. This event was not just a display, but a bold statement of Russia's prowess in modern military technology. During the exercise, MiG-31K jets carrying the Kinzhal provided flawless cover for bombers, successfully destroying 60 targets across 12 different categories. Based on the 9 M723 missile from the Iskander-M system, the Kinzhal is devastating, with a range of up to 1,200 miles. It also boasts a speed 10 times that of sound. Frightening, isn't it? This weapon can carry either a nuclear or conventional warhead. According to President Putin, it is currently invincible, capable of overcoming all existing and future air defense systems. Could a missile capable of penetrating every layer of defense be Russia's strategic trump card in potential conflicts? Share your thoughts below. But it doesn't stop there. Moscow is also experimenting with integrating the Kinzhal onto the next-generation Su-57 fighter jet, promising a deadly duo that could redefine modern warfare. While Russia flaunts its strength with the MiG-31K and Kinzhal missiles, the United States is not sitting idle in the hypersonic race. Russia's remarkable progress has created strategic pressure, pushing the Pentagon to seek new solutions to maintain its technological edge. This is where the SR-72 comes in, a highly ambitious project designed not only to catch up, but to surpass what adversaries can achieve. The SR-72 is not just a project. It is a strategic solution the U.S. cannot afford to ignore. In fact, the U.S. has successfully conducted 3 hypersonic missile tests, with some components manufactured at NASA's Wallops Flight Facility in Virginia. However, the biggest challenge remains finding the right propulsion system for the SR-72. Could Elon Musk, with his boundless creativity, provide the answer? Like hypersonic missiles, hypersonic aircraft face complex technical challenges. While missiles travel in a single direction and accelerate through simple stages, hypersonic aircraft must be more versatile. They must take off, land, change direction, adjust altitude, and maintain performance across all 3 speed ranges: subsonic, supersonic, and hypersonic. How can this puzzle be solved? Let's recall the first manned hypersonic aircraft, the X-15. It achieved a speed of Mach 6.7 during suborbital flights, but required a B-52 Stratofortress to lift it into the air before launch. However, for the SR-72, this method is impractical. Instead, it requires an advanced propulsion system capable of operating from low speeds to hypersonic speeds without needing configuration changes mid-flight. Imagine an aircraft as fast as a missile, yet as agile as a fighter jet. What are your thoughts? In the early stages of the project, Lockheed Martin and Aerojet Rocketdyne achieved a major breakthrough: the turbine-based combined cycle TBCCC propulsion system. This engine system is not only the heart of the SR-72, but also a technological marvel that transforms it into a game-changer in aerial warfare. The TBCC represents an incredible revolution by combining 2 technologies previously thought incompatible: traditional turbine jet engines for subsonic and supersonic speeds, and scramjet engines for hypersonic speeds. This integration allows the SR-72 to seamlessly transition between speed regimes, making it more flexible and lethal than ever before. When the SR-72 takes off, its turbine engine accelerates it smoothly like any other fighter jet. But once it reaches supersonic speeds, the TBCCC activates the scramjet engine, igniting airflow through the combustion chamber at incredible velocities. This machine not only accelerates, but almost disappears from radar, becoming a supersonic phantom that no one can keep up with. However, to realize this idea and develop the SR-72 prototype, Lockheed Martin requested funding of up to $1 billion. Immediately, Elon Musk stepped into the fray, proposing a solution at a much lower cost. He had previously demonstrated this capability with the Raptor engine, considered one of the best rocket engines in history. Can Musk continue to achieve such feats? Another major challenge for the SR-72 is the aircraft's hull. Speeds above Mach 5 generate extremely high temperatures due to plasma formation on the surface, something most current alloys and composite materials cannot withstand. Instead of using super expensive materials like composites costing up to $200 per square meter, SpaceX chose regular stainless steel for the Starship at only 1/100th the cost. For areas subjected to high thermal loads, Musk and his engineering team designed a simple yet effective cooling system. This is Musk's outstanding innovation, not relying solely on complex technology, but also optimizing simple, sustainable solutions. What do you think about this approach? Many experts believe simplicity is often the key to success. If you agree, leave a number 1 in the comments below. Stealth technology has been a game changer in modern aviation. While early developments in stealth can be traced back to the 20th century, exemplified by the SR-71 Blackbird, it wasn't until the introduction of the 5th generation F-22 Raptor that stealth truly defined a new era of aerial warfare. Since then, stealth has solidified its place as a cornerstone of modern military strategy, proving its value time and time again on the battlefield. Looking ahead, the proposed SR-72 is set to revolutionize aerial combat as a 6th-generation fighter. To achieve this, it must surpass the stealth capabilities of the F-22, which remains the most elusive fighter ever built. According to the U.S. Air Force, the SR-72 will feature cutting-edge stealth enhancements, including a sleek triangular shape, internal weapon storage, and the absence of vertical stabilizers. This radical design marks the first fighter to adopt such advanced aerodynamics. Key to this innovation is active flow control, a concept pioneered by the B-2 Spirit bomber. Unlike traditional stabilizers, active flow control uses onboard computers to dynamically adjust airflow around the aircraft, much like how birds control their flight. This results in unparalleled stealth, making detection by radar nearly impossible. The B-2 Spirit, which has maintained its title as the stealthiest aircraft for over 3 decades, serves as proof of the effectiveness of this technology. One lesson history has taught us is that no aircraft is ever truly complete. There is always room for improvement. Future jets like the SR-72 are being designed with open architecture systems to accommodate upgrades quickly and efficiently. This approach allows for interoperability, adaptability, cost-effectiveness, and easier maintenance, enhancing mission readiness. With an open architecture design, the SR-72 can be equipped with specialized tools and systems tailored for specific missions. Even more impressively, it could be upgraded to evolve into a 7th-generation fighter by integrating advanced components without requiring a full redesign. As a multi-role air superiority fighter, the SR-72 will be outfitted with cutting-edge sensors capable of detecting threats, targets, and allies from vast distances. Instead of traditional mounted radars, the SR-72 will incorporate smart skin technology, integrated sensors built directly into its fuselage. This provides seamless real-time data collection and situational awareness. Additionally, the SR-72 will operate as part of a networked fleet, enabling aircraft to share critical data instantly. This connectivity ensures that pilots remain updated on battlefield conditions, providing a significant tactical advantage. When it comes to firepower, the SR-72 will leave no room for compromise. Unlike the SR-71, which was unarmed, the SR-72 will carry an array of lethal weapons. Its arsenal is expected to include high-caliber cannons, precision-guided bombs, advanced missiles, laser weapons, and even autonomous wingman drones capable of executing missions independently. Simply put, the SR-72 will be armed to dominate the skies. Despite being retired, the SR-71 Blackbird still holds the record as the fastest jet ever built, reaching speeds of Mach 3. However, the SR-72 is poised to shatter that record, boasting a top speed of Mach 6, twice as fast as its predecessor. Such blistering speeds would grant it unmatched air superiority, enabling it to outrun any potential threats. Remarkably, the SR-71 was never shot down during its service, relying on its speed to evade enemy defenses. The SR-72 aims to build on this legacy, combining hypersonic velocity with next-level stealth and advanced weaponry to ensure it remains untouchable. The SR-72 represents the pinnacle of modern aviation technology. With its revolutionary stealth design, open architecture, state-of-the-art sensors, devastating weapon systems, and record-breaking speeds, it promises to redefine air dominance for generations to come. As it takes flight, the SR-72 will not only carry forward the legacy of the SR-71, but also set new benchmarks for the future of aerial warfare.